Right, going into vectors. So vectors, if you've taken physics or can remember physics, it's a lot of physics. We're just kind of going into the mathy side behind it. But you will see a lot of relationships here if you have taken physics before and can remember it. So again, you can read all through this. One thing you do want to remember is your distance formula. So I do have your distance formula listed in here as well as the slope, because the slope helps us, for now, find the direction. All right. So example 1, determine if the vectors are equal. So to show that two vectors are equal, we need to show that they have both the same magnitude and the same direction. So magnitudes like length, direction is steepness in terms of rectangular coordinates for now. All right, so vector u, notation for u. So when it's typed, you notice it's a bold. We don't have the ability to bold something when we are handwriting it. I can't just like darken it. So what I'm going to do is just show magnitudes that double, oops, what did my pen work? Double bar and then put a bar over it. Because I can't, like, I'm not just going to go in here and like say, okay, now it's bolded. No. Anyways, I'm going to write that a little bit neater because that looks terrible. All right, so u, magnitude first. So magnitude is distance formula, difference in the, it's think Pythagorean theorem-ish. Difference in the x values, quantity squared, plus difference in the y values, quantity squared, all square rooted. So x's are -5, -2. So -5 minus -2, quantity squared, plus difference in the y's. Make sure you pair them up correctly. 2 minus 6, quantity squared, all under a square root. So -5 minus -2 is -5 plus 2, -3, -3 squared, 9. 2 minus 6, -4 squared, 16. 9 plus 16, 25, square root of 25, 5. So the magnitude of vector u is 5. So now I'm going to go compute the magnitude of vector v. So we'll just go ahead and put it down here. All right, vector v. Difference in our x's squared. Let's go 2 minus 5. Plus difference in our y's. I started with the 2, so 2 minus 6. Quantity squared, all under a square root. 2 minus 5, -3 squared, 9. 2 minus 6, -4 squared, 16. That is 25. Square root is 5. So we know they have the same magnitude, because the same length. To verify that they have the same direction from rectangular coordinates, we're looking at slope. So we want to show that the slopes are the same. So slope formula, let's go with purple now. So to show slope of vector u, so I'm just going to do m with like a little subscript vector u just to show the slope of vector u. Difference in y's divided by difference in x's. So y's, y2, 6 minus y1, 2. So 6 minus 2 over difference in our x's, -2 minus -5. Which gives us 6 minus 2 is 4. -2 minus -5 is plus 5, so positive 3. So the slope of u, vector u, is 4/3. Now I want to go find the slope of vector v. So same formula, difference in our y's. Let's see if I can remember my points, 5, 6, and 2, 2. So 6 minus 2 over 5 minus 2. I think that was right. Yeah. 6 minus 2 is 4. 5 minus 2 is 3. So we have the same slope. So since they have the same slope and the same length, or the same magnitude and directions, the vectors are equal. So same magnitude and direction. Therefore, vector u equals vector v. Oops, why did I do it 2 bars? 1 bar. That one's too high. All right, some properties of vectors. So scalar multiplication. Scalar is a constant, so it's just the absolute value of k times the magnitude of v. It goes the same direction if k is positive. It goes the opposite direction if k is negative. Sum of two vectors, you can add using 2 ways. You can using the sliding method, tail to end, to connect them, or you can create a parallelogram and then the resulting sum is the diagonal of the vectors. Difference in two vectors, same thing, but you turn the vector that's being subtracted into the opposite direction, and then again use a parallelogram to find the resulting vector. Again, we've got vectors in the form of I and j, so the ij component of the vector, an I component is the horizontal component, the j component is the vertical component. So similar to like an x-axis and a y-axis, the I portion is kind of like the x-axis, the j portion kind of like the x-axis. So we want to sketch the vector 3i minus 3j and find its magnitude. So first is our sketch. So I'm going to come over here. All right, so vector ij, this is our I component. Vertical is our j component. So we are going out 3i. So that would be this right here, 3i. And then we are going down 3j. So this right here would be, whoops, I think that's straight, j. So our resulting vector is, we would connect the dots with those 2 points. I would like an arrow. Get that tip right on there. Here. So our starting point for this would be the point 0, 0. Our terminal point of the vector would be the point 3, negative 3. All right, magnitude. Magnitude, kind of like the distance. So when we write it in terms of I and j, it's very Pythagorean theorem-ish. It is Pythagorean theorem. So the magnitude of vector v is the I portion squared, so the a, 3 squared, plus the j portion, or b squared, square rooted. So the magnitude of vector v is 3 squared is 9, plus negative 3 squared is also 9, square rooted. Gives us the square root of 18, which does not come out nicely, but we can rewrite it as 3 square root of 2. Right, vectors in rectangular coordinates. So if we have 2 vectors, we can, not 2 vectors, if we have a vector with starting point P and terminal point Q to find the resulting vector, it's the difference in the x's and the difference in the y. Same thing we just did when we were in rectangular form. Okay, so example 3, v be the vector with initial point P1 and terminal point P2. Write v in terms of I and j. So it's important to know what the initial point is versus the terminal point. So we got to make sure we get that direction correct. So terminal minus initial for the I portion, terminal minus initial for the j portion. So v is going to be, let me put my bar over it since I can't bold it, terminal minus initial for I. So terminal minus initial is going to be, remember, careful, we're doing x first, 2 minus negative 1. Plus terminal for j, 7 minus 3. So if we look at that, that gives us 2 minus negative 1, 2 plus 1, 3i plus 7 minus 3, 4j. adding, subtracting, scalar multiplication. So these are properties of vectors. So it translates to scalar multiplication, think distributive property. Addition, think sum of each of the corresponding I versus j parts. Difference, think subtract the corresponding I versus j parts. All right, example 4. V is 7i plus 3j, and W is 4i minus 5j. We're finding each of the following. So vector V plus vector W. Sum the i's, sum the j's. So i's, 7 plus 4. I plus 3 plus negative 5j. So that gives us 7 plus 4, 11i minus 2j. All right, V minus W, so make sure V comes first. So V, so the I part's first, 7 minus 4, I plus 3 minus negative 5. Which gives us 7 minus 4, 3i plus 3 minus negative 5 plus 8j. All right, scalar multiple of V. So we're multiplying the vector V by negative 5. That transitions, think distributive property. Multiply each of the corresponding I and j parts by your scalar. So negative 5V is going to be negative 5 times, I don't remember what I was for V, 7. Yes, 7 and 3. Plus negative 5 times the j portion, which was 3. And that gives us negative 5 times 7, negative 35i, plus, or I guess I should do minus 15j. All right, properties of vectors. Make sure you read through your vector properties. I'm not going to read them to you. They're very similar to your standard addition subtraction properties that we've been over before. Finding a unit director who has the same direction as a given non-zero vector. You just take said vector and divide it by its magnitude. Okay, so that's what this formula. Remember that double bars on the side, that is the magnitude of a vector. All right, example 5, find the unit vector in the same direction as the given vector V, 4i minus 3j. So I need to take the vector V and divide each of the parts by the magnitude, which kind of translates to multiplication of a scalar by the reciprocal of the magnitude. So first thing, let's go find the magnitude of vector V. Come on, zoom in. All right, so my double bars. So so it's in ij format, so that is the I portion squared plus the j portion squared, square rooted, or a squared plus b squared. So our a and b are 4 and negative 3. So 4 squared plus negative 3 squared, square rooted, which gives us 16 plus 9. 16 plus 9 is 25, which has a square root of 5. So to get the unit vector, which it doesn't tell us to call it a name, so we have no name to call it, but the formula is take the given vector and divide it by the magnitude of that same vector. So I'm going to take my given vector, 4i minus 3j, and divide it by the magnitude that we just found, 5, which now we're going to split it. So 4 fifths I minus 3 fifths j. All right, writing a vector in terms of magnitude and direction. So we haven't really brought a whole lot of direction in here. Now we're going to bring that in. So notice the reappearance of the trig. So what we do is to find the magnitude, to write a vector in terms of both its magnitude and direction. Vector v it's the magnitude of the vector times cosine of the angle I plus the magnitude of the vector times sine of the angle j. Right, and a lot of where this is going to be used is going to be your word problems. Like I said, we gotta make it have some meaning. All right, the jet stream is blowing at 60 miles per hour in the direction of north 45 degrees east. Express its velocity as a vector v in terms of I and j. So one thing we want to note here is the magnitude of a vector. The magnitude as far as vectors are concerned is like a speed, think velocity. So it says express its velocity. So the 60 miles per hour, that is the magnitude of our vector v. All right, just to give you kind of an image of what's going on here, we like our directions here. It says the jet stream is blowing at 60 miles an hour north 45 degrees east. So we've done this before. So what that means is north, and then when it says 45 degrees east, that means tilt it 45 degrees. So this angle here would be 45 degrees. That is not how we measure angles. We measure angles in standard position. So that's not the angle we're concerned with. Luckily, they are the same for this problem, but if I change that to 35, they no longer are. So be careful of that. Make sure the angle you're expressing it in is drawn in standard position. So that is the theta we are worried about. And then this right here is our vector. I guess I should put an arrow on it. That looks pretty straight. All right. So to get this thing expressed in terms of I and j, we know our theta, because that top angle is 45. I know my theta is also 45 degrees. My magnitude, we've got it listed up there, is 60. So V equals magnitude 60 times cosine of the angle 45 degree I plus the magnitude 60 sine of the 45 degree angle times j. We need to keep going. It doesn't say anything about express it in degrees. It says it's a vector v in terms of I and j, so I do need to simplify. All right, so v is cosine of 45, square root of 2 over 2, same as pi force. So square root of 2 over 2, plus 60 sine of 45. We like our 45s and pi force because they're the same. Square root of 2 over 2. Whoops, that's crooked. All right, 60 times square root of 2 over 2. We can reduce it to 30 square root of 2. I plus 30 square root of 2 j. Example, another one, 7. All right, two forces, force 1 and force 2, very creative there, of magnitude 30 and 60 pounds respectively act on an object. So what that means respectively is force 1 is at 30 pounds, force 2 is at 60 pounds. The direction of force 1 is north 10 degrees east. So again, tilted 10 degrees over from the up axis. The direction of F2 is north 60 degrees east. Okay. So as far as the image goes here, the 10 degree is going to be this little baby angle. Hold on. Little baby angle right in here. That's our 10 degrees. So if you wanted to find this one, that's 80. Our other one, I think it's at 60 degrees east. Yes, north 60 east. So that means this angle here is 60 degrees, which means if we wanted the bottom one, it would be 30. But we don't need that right now. All right, let me keep reading. Find the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree of the resultant force. So find the magnitude. So that's the resultant force. So that's the like tail to end of the vector. And then, so the length of it, and then the resultant, the direction, which would be the angle theta drawn to from our positive x-axis up to that resulting vector. So we got a lot we're doing here. All right, so first thing we need to do is we need to get each of our forces written in terms of their I and J components. Okay? So that means we're going to need a calculator here because we're not dealing with unit circle angles. So force 1. So force 1, I'm going to go draw on this picture right here. So force 1, to get it in terms of I and J, because we're given the angle measures, we've got to figure out our angle. So I'm going to correspond with theta 1 and theta 2. So force 1 was tilted 10 degrees east, so that means our standard position angle here is going to be 80 degrees. So theta 1 is 80. Magnitude of force 1 was 30 pounds. So we don't have to find it, we're given it. So the magnitude of force 1, did it say 80? No, 30 pounds, sorry. So writing our first force in its IJ components, F1 is going to be the magnitude, 30, times cosine of the angle, 80 degrees, I, plus magnitude, 30, times sine of the angle, 80 degrees, J. Okay, so we're going to have some estimates here. So since we're asked to round to 2 decimal places, I'm going to give my answers right now. Let's see, for force 1. I'm going to write my answers down to 3 decimal places so that the resultant vector, I can round it to 2 decimal places. All right, so F1, we're doing a little calculator here. So watch the mode of your calculator once again. Make sure you are in degrees or you're going to do this wrong. So 30 times cosine of 80. That gives us F1. Like I said, for now, I'm going to use 3 decimal places. 5.209I plus, now we do 30 times sine 80. We get 29.544 J. So there's our IJ form of force 1. Force 2, I'm going to do in a different color. Force 2 was tilted at a north 60 degree angle. So force 2 is coming all the way down here. That is 60, which means our standard position angle that we need for force 2 is going to be 30 because they have to make a right angle. So we're not worried about the 60, we're worried about the 30. So I'll erase that. All right, so theta 2 is 30 degrees, and the magnitude of force 2 is 60 pounds. All right, so force 2, I guess I should put my bars over my vectors. I'll go back and get that bar on there in a minute. 60 cosine 30 degrees I plus 60 sine 30 degrees J. Right. So technically we could do this one using our unit circle, but the other one's already in ugly decimal form anyway, so we might as well just go ahead and make a match. So 60 times cosine 30, make sure you're in degree mode, 51.962 I plus 60 times sine 30, 30J. So there is our IJ form of force 2. The resulting force, both of these forces are being applied in the same direction. Therefore, our resulting force is going to be a sum. If they're in different directions, that's where we get complicated. But they are applied in the same direction, so we're going to add to get our final force. So our force, F, oh yeah, I was going to put my bars back. Bar, is going to be found by adding the corresponding components. So I'm going to take my I terms and add them, and I'm going to take my j terms and add them. So for F1, it was 5.209 plus, for F2, the I portion was 51.962 plus, then we go get the j portions, 29.544 plus 30 j. And then we do a little math here, so 5.209 plus 51.962 gives us 57. And we were supposed to go to 2 decimals, I believe, here. Find the magnitude to the nearest hundredth. So it's not quite to the magnitude yet, so I'm going to leave 3 decimals. 57.171 I plus, and then we've got our 29.544 plus 30, 59.544 j. So this is our resulting vector. So to find the magnitude of the resulting vector, we go Pythagorean theorem it. So the magnitude of this final force is the I portion squared plus the j portion squared, all under a square root. So square root. So 57.171 squared plus 59.544 squared. And then we take that value and we square root it. And we get 82.54. So back to the units. The units for the forces 1 and force 2 were in pounds. So the unit of the resulting vector is also going to be in pounds. Now you're not going to have to type the units in, but it does kind of help to know it is the same. All right, as far as the angle. So technically we could use either the horizontal or vertical component. I like the vertical component. So recall the magnitude of the vector is equal to the A portion times cosine. So if we're trying to get theta, so I know that the magnitude of the vector is equal to A cosine theta. Well, I have the magnitude and I have A, so I can plug in here and solve for theta. So I'm going to go ahead and solve for theta first. So first thing we would do is divide by the A. So cosine of theta is wait, I wrote that upside down. Hang on. Hold up just a second. I wrote it backwards. And A is the magnitude times cosine theta. There we go. That looks better. So to get cosine theta by itself, we would divide the magnitude off. So I know that cosine of theta is equal to A divided by the magnitude of that final force F. To undo cosine, we use inverse cosine so that theta is the inverse cosine of this ratio A over magnitude F. You could use sine, but I like cosine better. All right, so I'm going to go get my values and plug in. A back up here was 57.171. Over our final magnitude up here somewhere, 82.54. And then we go calculator it very carefully, so make sure you're in degrees still. Inverse cosine, not cosine, make sure it's got the -1 on there. 57.171 divided by 82.54. And we get a resulting angle of, I forgot how many decimal places it said. 1? Let's see, way back up here, to the nearest 10th of a degree. Okay. So the nearest tenth of a degree, it would be 46.2 degrees. Right, once again, careful with the mode of your calculator. That's the unfortunate thing. The higher you go, you've got to start toggling back and forth. For these problems, when you're in degrees, make sure you change your calculator to degree mode.